This is Mastering Mathematics with your teacher, Karen Weston.
Hello Antigua, Barbuda. Welcome again to the second in the series for the year 2014 to 2015, Mastering Mathematics. Program sponsored by the Ministry of Education using its EBU unit and the Center for Mathematics Education. What did we say we were going to be doing? Yes, the topic we're dealing with, matrices. Do we have time to talk? No, because we have a lot of work to do, because we know how quickly the year comes. And what are we going to do this year? We're going to pass mathematics. We're not even going to say what the percentage increase will be, because we expect everybody to pass mathematics, and that's what we're aiming for. Okay, so we started with our topic, matrices, because again, you know that we have all these things on YouTube, so that you can go www.youtube.com/Mastering Mathematics, and you will get it in. Somebody say just have to Google YouTube Mastering Mathematics. You can see that everything we did already before, they are right there. Next week I'm going to tell you also what we actually have done to the unit. We have increased some things, put in other stuff so that you can see all these things, and I hope that by the end of the year you will have solution for the questions. Also remember the CXC website, that the past papers are right there, and you students, you are now the learners, you are the facilitators. Teachers are only just there, yes, to facilitate your learning, but you are in charge. You are large and you're in charge of your learning. Okay, so we are going to make certain that we give you your resources, and we make everything available for you, things to be easy for us to learn and master mathematics. What did we start with yesterday? The topic, matrix. We gave you your definition. We gave you the words that we're using. We gave you the order of the matrix. Today, we want to start where we're going to talk about the different types of matrices. Okay? So, we have our different types of matrices, and don't forget we tell you exactly how this information is being used, and you can find some more examples for us using your computers and these iPods. Okay, now the first type we have is called our row matrix, and the row matrix, because row matrix has only one row. So for example, we have A would be equal to, and you can have 3, 4, and there's 5. One row. Okay, and so it is called a row matrix. Secondly, we have our column matrix. Our column. Column matrix, and this column matrix also has only one column. So for example, you can see 2, you see 4, and we see 5, and they're in a bracket. And that is called a column matrix. Then we give you a matrix that we're calling a null matrix. A null matrix. And this null matrix has all elements that are 0. So, for example, we will be equal to, we have 0, 0, 0, 0. So all the members of that matrix is equal to 0. So can we say that is a matrix with all its elements 0? Okay. Now we stop for a minute, because what did I use? I used a word that we didn't talk about. So we have to start. What is this element Miss Weston talking about? And right one says, you're right. The members of a matrix is called its element. So teachers, we stop, and as a little aside, we give our definition for that new word, element, all right, that we just used. Don't go on unless it is explained. Do not take it for granted that they will pick up the meaning. All right, put it down there for them. So the elements are the members. They know that word, members. Members of the matrix. Okay? So the term that is used when we're talking about the members of the matrix is elements. Very good, make certain we know those. So we have about 3 words already associated with matrices. Isn't that true? Yes. We talk about matrix, and I'm saying matrices. So what did we get from that? That the plural of the word matrix is matrices. We cannot say that we will not examine English in the mathematics classroom. It is a vital and essential part of the mathematics classroom. We cannot say that we must leave those things to the English teacher. No, it is a part of the mathematics structure, and it must be taught simultaneously with numbers. All right? So, yes, so we know matrix, we know the plural for that, we know row, and we say when the numbers are in the horizontal position, we call them rows, and when they're in a vertical position, we call them columns. Okay? And now we're giving you the definition of the types of matrices that one can find in this topic, that at this level. And the first one we say is the row matrix, and we say row matrix has only one row, and the column matrix has only one column. The null matrix has all elements that are 0. So we give you that B would be equal to 0. So we have already copied these, so we're clearing our boards because I've divided it into 3 areas, so I can service some of my other thoughts, okay? So we've done that, and here we are now talking about a square matrix. A square matrix. Oh, it's like to get up in my hand. The square matrix. And what did we say the square matrix was? That it is a matrix having the same. So the square matrix is a matrix having the same number of columns and rows. Having the same number of columns and rows. So, for example, call this P this time. P, yes, because I used a P equal 2, 4, 6, 7. And we have 2 rows and 2 columns. How do I know this? Because this is 1 row. That's the second row. And if I had to go in terms of my columns, this would be the first column. And that would be my second column. Okay, so the same number of rows as columns. So we have our square matrix. Then we have our diagonal matrix. And for this, it says it is a square matrix in which all the elements are 0 except the diagonal elements. Okay, so this one is the diagonal matrix. And you know what? This is saying a mouthful. So I'm going to send you on your break. Let you consume and let you absorb what a row matrix is, what a column matrix is, the null matrix, the square matrix. When we come back, I'm going to tell you about the diagonal matrix and the unit matrix. You're not going to forget your diagonal matrix because that is how learning takes place by association. And you're going to remember those 4 because you're going to say, yes, when we're learning the definition, she gave us the first 4 and then sent us on a break, and then she gave us the last 2. So at times, learning takes place by association. And my primary school children, when I come back, I'll give you the answer to that question we gave you yesterday. So do enjoy your little break and we'll be right back.
Don't look on what I cannot do. Focus on what I can do. I may not say what I do, but I can hear and feel it as strongly.
I may not hear, but that does not and should not affect my ability to learn and to function in the real world.
I am a gifted student. I need the opportunity to soar. Support me in my climb to higher levels of learning.
Some of our children have special educational needs. They have a right to an education. So, let us teach them the way that they learn and help them to achieve their full potential.
Carefully read over the sections of your textbook assigned by your teacher and look carefully at the sample problems. Decide if you benefit more by reading before or after the instructor covers the material.
To succeed in mathematics, you need to build on what you have learned before. New concepts are added to and build upon previous concepts. It is very important that the early material be mastered thoroughly. Similarly, mastery of material from previous classes makes success in later classes more likely. So continually review and practice concepts from previous sessions.
Right, so we're off and we went for our break. And those with our matrices, what were we doing? Our row matrix, our column matrix, the null, the square. And I braked when I asked you to absorb the diagonal matrix. And what is it saying? It is saying that for a diagonal matrix, it is a square matrix in which all the elements are 0 except the diagonal elements. It is a square matrix, so we know square matrix equal number of rows and columns, and it is one in which all the elements are 0 except the diagonal elements. And so we have to tell you that our diagonal elements run from upper left to lower right. From upper left to lower right. So here we are, from upper left to lower right. And if we wanted just to say in layman's language, we'd be coming along to hope our first number, going through the middle and ending up at the last number. So any numbers along that line, all right? Those would be our numbers that we're talking to say the elements run from upper left to lower right. So when we would have left out all the elements along that line, the other members of the matrix would be equal to 0. And finally, we come to our unit matrix. Our unit matrix, okay? And yes, you're listening to me talking more than saying, let me see what she wrote, because this handwriting will drive you crazy. I know that, okay? But don't go bad with it, because what did my headmaster tell me in school? Bad handwriting is a sign of intelligence. So we don't care when they say we can't write, all right? Bad handwriting is a sign of intelligence, okay? But nice handwriting is also a sign of intelligence, so don't take it for granted, okay? Good. Here we are. Now we are going on to our unit matrix. And what is the definition here? It says the unit matrix is a diagonal matrix. Remember, we just told what a diagonal matrix was, okay? In which the diagonal elements, and we just told you, right, first with last, is equal to 1. So it is a diagonal matrix in which the diagonal elements is equal to 1. So here is our example for our unit matrix, and it is equal. So our unit matrix, here we go, it's equal to, and it is 1, 0, 0, 1. Okay, it is 1, 0, 0, 1. So all the elements running from this upper left to lower right, that would be equal to 1. And we have to commit to memory this matrix, because it is going to be mixed with partners from reflection in the y-axis, reflection in the line equals negative x. Jetty, you know them, isn't it? Rotation around, okay, and asking you which of these would represent a specific matrix. And this would be the identity matrix for the topic matrices. Because yes, we can get other things that can look like this. 1, no, you can have 0, negative 1, 1, 0. And you can ask me now again which one it is. It's a reflection in the line, probably y is equal to negative x. And I am saying that to tell people, every time you learn mathematical fact, if you're not using it, it does not stay in your brains. Okay? And I am tired of hearing people telling children they didn't have any foundation. That is a cheap way out. Because every time you start a topic in mathematics, you must take them from the beginning. You must start again and bring them up to the level where you want to. No, there are no cement poles in our brains, and no, the mathematical language does not stay. It's good if we know that we have been using it, so we're familiar, and it comes right back and say, oh yes, but it takes a little time. I would have been teaching these things for over 40 years, but you can't ask me, just punch and say, what is this? And I would say right away, it's a reflection in the line, y is equal to negative x. If I say that, I would have looked at it before. All right? But every time you switch to another topic, right, you have to go back for your brush up. So stop telling students, oh, you didn't have a good foundation. So now they've met you, tell them that I am going to teach you my brand of mathematics, and it does not matter what went before, because from day one, you are going to learn what you missed, and you will see how those children flourish. Okay? So that is what we do. And stop talking about not having foundation. Foundation comes from you and whenever you meet them. Okay? Promise yourself that you can do that. So again, that then is our diagonal matrix. This is our example of our unit matrix. So the unit matrix is a diagonal matrix in which the diagonal elements equal 1. In which the diagonal elements equal 1. Alright, so for today, mostly, my adults, you were learning the types of matrices, the order of the matrix, so you know what we're going to do the next time. Yes, we're going to start looking at the operations involving matrices. It is as simple as that. Take your time. Don't say you never had any foundation. Don't say you never landed somewhere you may go to school. Alright? Learning takes place as soon as you get the new knowledge. And it's not stored for a particular age or anything. Okay? Now, just before we end off, we have with primary school students. I gave you some work. I gave you a question the last time. And I had asked you to use 4 cards. And the cards were 9, 5, 9, 2, and 4. You can shuffle them if you wanted to, okay? And they have. And I was asking, what is the largest possible odd number that you can form? And we would have looked, and we would have seen that we really had 2 odd numbers with which to work, and they were 5 and 9. But if we put 9 at the end, then that would not be the largest number. The largest number would have to start off with a 9. So that meant that we would have used up one of the odd numbers. And the largest possible odd number, the other odd number has to be at the end of the number. Isn't that true? Yes. And then after that, now, so what are we doing here after that? We're fixing 2 numbers that we have left. And it is our 4 and our 2. So which would have given us a larger number, 24 or 42, okay? And then so when we put them in our slots, now we would have gotten 1s, 10s, 100s, and 1000s. So that the largest possible number would have been 9,425. It's all a game, all right? Yes, and that was an exam question. Then we were asked to use only 2 cards together. What is the largest possible square number? And we tried, and so it's 2 cards we were asked to use. And if you do it, you're going to see that the largest possible square numbers that I can get would be 49. Okay? If you want a larger one, you tell me. But that is it, because you know 59 is not a square number, 95 is not a square number. Okay? So nothing would work for us. So the largest one we got. Because what is a square number? Right, any square number means a number multiplied by itself, giving us a product, okay? So that is where we get the square number from. And the square number, we know what number would that have been here, and we know right away because we know tables should have been 7 times 7. The third one asked us to arrange the number cards to construct a subtraction problem to give the largest possible answer. And then again, we started playing here again with numbers. The largest possible number has to start with 9, isn't that true? Yes. So it's 9 something. And it was the biggest 100 we can get out of it. And it came from our 5. And the biggest 10s position would have been coming from the 4. So in our estimation, we said the largest, the cards, when we arrange them to give the largest possible answer, would have been 954 minus 2. And that is what we gave for that answer. So in the examination room, nobody's asking for a record these days. They're asking for construction and for you to apply what we know. Because in this position, we were dependent on our knowledge of place value to see us through. we were depending on our knowledge of what a square number is, the definition of an odd number. So notice they're not just going to ask you what is an odd number and you give a definition. You have to know it and then use it as application. So that is what is being done now in our schools. And therefore, again, I remind the people in the primary school for the projects, it's also application of the mathematical knowledge that you would have been giving your students. That notebook that came out in 2006, that was to facilitate the first time the project was being introduced in Antigua Barbuda, and my teacher said they needed to understand what do we mean by a mathematics project. It is not there as the gospel or any Bible to say that it is one of the topics that's being demonstrated or talked about in that book that you have to use as an assignment for your student. No, the innovation and the creativity exhibited in the project must come from you and your students, not from Karen Weston, not from the Ministry of Education. We can guide you in terms of, say, presentation and format, but not what your stuff should be. Okay? Oh, and here we would have been giving you the answer for this one, which is 952. Okay? So our answer for that sum that we were talking about. So again, I don't want any teacher to say that it is out of the book and that was the topic, or else I am coming to put those books on fire. All right? They are not, that knowledge has now been obsolete, and you must make your students do the new stuff that they're seeing and create what they want. So don't bog them down with saying they have to do a project and it has to be large numbers or it has to be statistics, because that's, no, nothing in the book is right, okay? What in the book is correct is the knowledge, and that you can be given information as to what is meant when we start talking about projects, be it a mathematics project or a science project. But you're not going to get, this is not science, so you're not going to hear Karen Weston saying, this year I want students to prepare. That is not creativity. And that is what we're thinking, and we want our students to be innovative, creative individuals. So let us continue to make the mathematics classroom an exciting place for our students. Continue to take your time to teach them, and our teachers in our secondary schools, and especially those who are now sending out our students into the real world, let us continue to allow them to see how easy it is to negotiate the information that will be required in a mathematics exam. Again, CXC has provided us with materials. Remember, you also have www.caribbean.com, and you can go and get new materials there too, okay? Our website, okay, Mastering Mathematics, YouTube / and you can go there again, and everything is made available. And don't forget, you can visit us here at the center, and you can also get some of the things that we would have done before, so you can stay anywhere in this world and learn your mathematics. You are now in charge of your learning students. We as teachers and educators are the facilitators. Do enjoy the rest of the week, and next week we will be delighted to come to you once again. We will be starting the operation and get you cracking and to show you that even just after one session, you will be ready to work the first part of any matrix question on that section 2 of the CXC examination paper. Keep on learning, because knowledge is power.
Join us next time for another in the series, Mastering Mathematics, a production of the Education Broadcasting Unit in the Ministry of Education and ABS TV.